Hello everyone, today I will show you how you can find the hold SNM and the read SNM using the simulation tool. So what's the methodology you should follow to draw the HSNM and RSNM? For the hold SNM, it's just so if you can see an SRAM, so you have this cross coupled inverters and you have this excess transistors. This is word line, this is your bit line, and this is your bit line bar. So hold means you there will be no connection between the bit line and the internal node. Let's say internal node is Q and this is Q bar. So we turn off the word line is 0, bit line is also, it doesn't matter as word line is off, so there will be no connection in the state here will be retained. So this is the hold state. So how you can plot the HSNM for that? So what you do, you just sweep the voltage at Q and plot the Q bar. Okay, how the voltage here varies when you sweep the Q. So you apply a external voltage and sweep it from, let's suppose from 0 to 1. So you get the Q bar something like this. And now in next step, you apply a external voltage, means you change the node from, let's suppose this is V1, so V1 transfer to here. So you sweep the Q bar and Q, you get something like this. So you exchange the axis and then plot both the VTCs. So your VTCs should look like this, and you find out the maximum size of the square that can fit inside these states. Okay. Similarly, RSNM is also plot like this. Just the case is the read case. So in the read case, so you have cross coupled inverters here. You have these excess transistors. This is your bit line. This is your bit line bar. This is your word line. This is your word line. Okay, it's connected like this with a wire. So in the read, you have to access this Q and Q bar nodes, whether it's 1 or 0. So what in that case, what is the voltages here? So in the read case, you apply word line equals to VDD, bit line is what? This is also VDD, bit line bar is also VDD, and then in that case, you apply an external voltage here, sweep the Q, plot the Q bar, something like this you get. Then you put the supply voltage here and plot the Q versus Q bar. So in the read, you will also get something like this with something like this characteristic. Okay, in the reads. So you fit the maximum square that can fit in these lobes and find out the RSNM values. So this is how you find the hold SNM and the RSNM of any SRAM cell, 60 or 80 SRAM cells. So this is all the place for the folks.